Here are the group report of Group 1 on standard test method for compressive strength of hydraulic cement mortars. The objectives of this lab report uh, is to provide information that will determine the compressive strength of hydraulic cement mortars using 2 inches or 55 millimeter cube specimens. The test method uses either inches pound and SI units, and the system must use independently because the value in each system is not equivalent. This experiment does not claim that all of the safety procedure will be applied, so anything that will happen is responsibility of the user.
Introduction for the standard test method for compressive strength of hydraulic cement mortars. First, in using this test method, it is possible to determine the compressive strength of hydraulic cement mortars. The results gathered or shown from this test method will be useful to determine the available specifications while adhering the rules about it. The second one, this test method can be considered as an allusion of various specifications in different test methods. In simple words, this method is already referenced by some specifications in other test methods. Third, the results from this test method are important and must be accurate for the use to foresee or determine the strength of concrete. It is just saying that the result must be accurate because it might greatly influence the final result of an experiment. That's all for the introduction, and next is about the instruments.
Here are the list of instruments for hydraulic cement mortars. First, weights and weighing devices, class graduates, specimen molds, mixer, bowl and paddle, flow table and flow mold, tamper, trowel, and testing machines. So the first one is weights and weighing devices. The weights shall conform the requirements of the specification C1005. The weighing devices shall be evaluated for precision at a total load of 2,000 grams. Plus graduates, much, prefer- much preferably much larger enough to mix the water in a single operation. Specimen molds. It is must be 2 inches or 50 millimeter cube specimens. The molds shall not have more than 3 tubes compartments and shall not have more than 2 parts. Mixer, bowl, and paddle. Used to mix the specimens, an electrically driven mechanical mixer of the type equipped with paddle and mixing bowl. Flow table and flow mold. With the mold removed, the test specimen will flow and will drop and raise a specific number of cycles. Tamper. The tamper used to flatten the surface of the test specimen. Tamping face shall be flat and at right angles to the length of the tamper. Trowel can be used to digging, also smoothing small amounts of particles on test specimen. Testing machine, of course, to test the specimen.
The content of this part is the procedures to be performed in the test method. The procedure is divided into 6 parts. The preparation for the composition of mortars, procedure for mixing the mortars, which is based on ASTM-C 305, the determination of cement flow, based on ASTM-C 1437, process of molding the test specimen, proper way of storing the test specimen, and last, the determination of mortars' compressive strength. For us to better understand the procedure, here's a video that will demonstrate the process used in this test method.
For the designation C109C and 109M, the formula is Fm times I equals P over A. Then Fm equals summation of I equals N times Fm of times I over N, wherein Fm times I equals compressive strength of specimen in MPa. Then P equals maximum load, A equals area of loaded surface in millimeters squared. Then Fm equals average compressive strength in MPa. Then the I equals the series of specimens. Then the N equals the total number of specimens.
Data and result. Number of cement is 250 grams, sand is 687.6 grams, and water is 121.26. Age of cube is 7 days. Number of specimen is 1, 2, and 3. Area of loaded surface in millimeters squared. In trial number one specimen is 5 by 5. It's equal to 2,500, and its maximum load in kN is 54.04. Compressive strength of specimen is 21.62, and the number of specimen number 2 is area of loaded surface is 49 by 49 equals 2,401. Maximum load is 60.02. Compressive strength of specimen is 25. And in number 3, 50, area of load is 50 by 50 equals 2,500. Maximum load is 63.03. Compressive strength is 25.21. Average of all 3 specimen is 23.29. In trial number 2, it's also an age of cube is 7 days. There's also 3 specimen. First specimen is 50 by 50 equals 2,500, and that's the area loaded. Maximum load is 53.05. Compressive strength of specimen is 21.22. And number 2 specimen is 49 by 49 equals 2,401. Maximum load is 51.05. Compressive strength of specimen is 21.26. And specimen number 3, area of load surface is 50 by 50 equals 2,500. Maximum load is 55.03. Compressive strength of specimen is 22.01. Average compressive of the 3 is 21.5. In trial number 3, it's also 7 days. Number of specimen is also 3. First specimen in area of loaded surface is 50 by 50 equals 2,500. And maximum load is 53.03. Compressive strength of specimen is 21.21. In specimen number 2, 50 by 50 equals 2,500. Maximum load is 63.09. Compressive strength of specimen is 25.24. And the last one is specimen number 3. Area of load is 50 by 50 equals 2,500. Maximum load is 53.03. Compressive strength of specimen 21.21. Average of all specimen is 22.6. These are the average compressive strength in 7 days of the trials. Trial number 1 is reported to be 23.9. The average compressive strength of trial number 2 is 21.5, and the trial number 3 is 22.6.
Computation. For the computation part, we will be using the values in the data and using it for the formula. So for trial number 1, in getting the compressive strength of each specimen, we will be using this formula. So first, we need to convert our given maximum load since it is in kilonewtons. Based on our formula, it should be in newtons. So 54.04 times 1000 newton over 1 kilonewton. The kilonewton will be cancelled. Therefore, it will be 54,040 newtons. Now, we can use it in the formula by dividing our newtons or 54,040 newtons over our cross-sectional area for our first specimen, which is 50 times 50. By using our calculators, it will be 21.62 megapascal. So for the second and third specimen, the steps will be the same by first converting it to newtons, our load, and then using it for the formula to get the compressive strength. Now that we've gathered all of our compressive strength in each specimen, we can now determine the average compressive strength of trial 1. We can do it simply by adding all of the compressive strength, 21.62 plus 25 plus 25.21, and dividing it by the number of specimen, which is 3. Calculating it, it will be 23.9 since it is rounded to the 0.1 MPa. So for trial 2 and 3, the steps will be the same as what we did in trial 1. So next part. After computing all of the compressive strength and average strengths of the 2 trials, we can now compute for the range. So based on the formula, we will be using the average compressive strengths in each trial and multiplying it by 8.7% since we have 3 cubes. So for the first trial, 23.9 plus 23.9 times 0.087 using our calculators it will be now 25.98 megapascal. And then we will now subtract it, 23.9 minus 23.9 times 0.087 equals 21.82 MPa. The steps will also be the same for second trial and third trial. These values that we have compute only means that these are the ranges that the value of the specimen should be. That's all for the computation.
Drawing in figures. Here in drawing in figures, ipapaliwanag natin yung procedure. So, ang procedure dyan is, i-prepare natin yung mga materials natin, yung water, yung cement, yung sand, and ito, yung mga materials natin, dapat may required niyang measurement. And, i-weigh natin sila. Pagkatapos natin silang timbangin, ilalagay siya sa mixer, sa bowl, and paddle. Yung cement muna and water. Then, tatimeran siya. Hindi pa kasama dyan yung sand. Dun siya sa susunod na pag-mix. Which is, ayan, ilalagay natin siya with respect to time. And after that, tapos na yung tinatawag nating mixing for mortar composition. Gagawin natin yung cement flow testing. Ilalagay natin yung composition dun sa specimen mold. Tapos, using yung paddle, para maayos yung yung composition niya, hindi siya magkakaroon ng mga bubbles, ganun. Or anything na pwedeng makasira dun sa composition. Tapos, next natin, gamitin natin yung trowel para i-flat yung surface sa taas. Then, next nyan is ito. Tatanggalin natin tong molder natin para mag-flow yung cement. Which is yung tinatawag nating flow testing. Then, ayan, pagkatapos niyan, pagkatapos niya mag-flow, syempre, i-measure na natin siya. Pagkatapos natin siya i-measure, gagamitin na natin yung tinatawag nating mixed molding of the specimen. Ay, nalagay na siya dun sa mortar. Nalagay natin yung mortar dun sa specimen mold. Then, using yung trowel para flatten surface. And, next natin is storage of test specimen. Pagkatapos mangyari yan, i-weigh natin siya kasi nag-compress na siya eh. And nag-compact na yung mga materials or yung composition. Dito na tayo sa pinaka-main objective natin is i-test yung compressive strength niya. Which is tatlo yung pwedeng mangyari. Ito, and ito. Ayan yung pwedeng mangyari sa material natin.
Sources of errors. Avoid specimens that are clearly faulty when calculating compressive strength. When 3 cubes represent a test age, the maximum allowable range of specimens from the same mortar batch at the same test age is 8.7% of the average and 7.6% when 2 cubes represent a test age. When the within batch coefficient of variance is 2.1%, it will more likely reach the range of 1 to 100. The average for laboratories involved in the cement and concrete reference laboratories, Portland Cement and Masonry Cement Reference Sample Program is 2.1%. If the range of 3 specimens reaches the limit in 13.2, discard the result which is different from the average and examine the range of the remaining 2 specimens. After discarding defective specimens or experiments that fail to comply with the maximum allowable range of 2 specimens, retest the sample if fewer than 2 specimens remain. Reliable strength result depends on strict adherence to all of the requirements and procedures. Erratic result at a given test period indicate that some of the requirements and procedures, such as those covering specimen testing as prescribed in 10.6.2 and 10.6.3, have not been carefully followed. Improper specimen centering result in oblique fractures or light testing. Improper centering of specimens resulting in oblique fractures or lateral movement of one of the heads of the testing machine during loading will cause lower strength.
Conclusion and remarks. The result presented showed that 38 inches in situ mortar joint will have a significantly greater compressive strength over a cube specimen made of the same mortar and tested according to the prescribed ATSM ASTM standard. The cooling process must be followed, the desired concrete properties, and to ensure that the concrete will have a sufficient moisture available to develop the required property.
Here are the reference that we use on this lab report. Next is the standard test method for time of settings of hydraulic cement by Vicat needle. The objective of this lab report is to help to determine compliance with specification limit for Vicat time of setting. It is said that the age and temperature of the water, the way you need the paste, the temperature of humidity of the room air, and the moist cabinet has an effect on measuring the time of setting. It will execute using 2 methods. The method A will perform using manually operated Vicat apparatus, while method B will perform using automatic Vicat machine.
Introduction for the standard test method for time of setting of hydraulic cement by Vicat needle. First, in using this test method, it is possible to determine the limit of a specification for Vicat time of setting. The specification of cement will be used as a reference to ensure if this test method is used for specification compliance. Second, when it comes to setting, it has several factors that may affect the measured time, such as temperature and amount of water, the process of kneading, and the condition of surroundings. Remember that all processes involved in this method might have impact to the results of the experiment. Third, this test method can be considered as distinct and anticipate that the measured time will be not necessarily the same to the others methods. Do not assume the results in this method are the same compared to the results of other methods. That's all for the introduction, and next is about the instruments.
So here are the instruments for the experiment of time of setting of hydraulic cement by Vicat needle. So Vicat apparatus, glass graduates, flat trowel, conical ring, mixer bowl and paddle, automatic Vicat needle apparatus, specimen mold, and plain non-absorptive plate. So for Vicat apparatus, this should have a removable rod. The end of the rod should have a removable needle for penetrating the sample. Glass graduates, it must be 200 or 250 ml capacity, conforming for the requirements of specification C1005. Flat trowel, having a sharp straight edge steel blade 100 to 150 millimeter in length. Conical ring, it is made of rigid, non-corroding, non-absorbent material. It should have a height of 40 positive negative 1 millimeter, diameter at the bottom of 70 positive negative 3 millimeter, and at the top is 60 positive negative 3 millimeter. Mixer, bowl, and paddle, it is discussed already. It is used to mix the specimen and electrically driven mechanical mixer of the type equipped with paddle and mixer bowl. Automatic Vicat needle apparatus. The instrument should be equipped with standard Vicat needle. It should have a 1.0 positive negative 0.05 millimeter diameter and have length of at least 50 millimeter. The instrument shall be capable of completing and penetration of test specimen at time arrivals not exceeding 10 meter, 10 minutes, and each penetration at least 5 meter away from the inner side of the mold. Specimen mold. For method B, the cement paste is held inside the conical ring with a height of 40 positive negative 1 millimeter and removable base plate. The surface shall have a minimum diameter of 60 positive negative 3 millimeter. Plain non-absorptive plate used in order to put the conical ring with specimen mold. 100 positive negative millimeter square of similar plainness absorptivity to that of glass.
The procedure for the standard test method covers two practices, Method A and Method B. They have the same process of mixing and molding the test specimens. The main difference between the two is the apparatus they use. Method A uses a manual Vicat machine, while Method B uses an automatic Vicat machine. For us to better appreciate the two methods, here's a separate video of the two that will demonstrate their processes.
Video we will cover setting time of hydraulic cement by Vicat needle. In other words, the time that cement need to react or hydrate completely with water. In order to perform this test, you need the following: the Vicat apparatus, 2 needles, thick and thin one, a mixer, a timer, a 650 gram of cement, and a defined amount of water, which has been determined by the normal consistency test, which we had covered in a previous video. Click here or on the link in the description box to see the video. First, put the cement in the mixing bowl. Then add the water to the cement. Run your timer at the exact time you have added the water to the cement. You need to prepare the cement paste as we have done in the normal consistency video. Leave your paste for 30 minutes. Place the thin needle on the Vicat apparatus. Set the indicator on 0. Adjust the needle until it becomes in contact with the base surface. Release the needle. The needle will penetrate the paste. Repeat this operation every 15 minutes until a 25 mm or less of penetration is obtained. The time between the initial contact of cement and water and the penetration of 25 mm is the initial time of setting. Then, place the thick needle on the Vicat apparatus. Set the indicator on 0. Adjust the needle until it becomes in contact with the base surface. Release the needle. The needle will penetrate the paste. Repeat this operation every 15 minutes until the needle fails to penetrate the paste. The time between the initial contact of cement and water and the fail of thick needle to penetrate the paste is the final time of setting. And by that, we were able to determine the setting time of hydraulic cement by Vicat needle.
Ayan na.
For the designation C191-04, the formulas are for the calculation of initial setting time, Ti equals H minus E over C minus D times C minus 25 plus E, wherein the Ti is the initial setting time per minute, the H is the time in minutes of first penetration less than 25 millimeters, the E is the time in minutes of last penetration greater than 25 millimeters, the C is the penetration reading at time E, and the D is the penetration reading at time H. For the calculation of final setting time, TF equals the product of 90 plus the product of 1.2 times Ti, wherein the TF equals the final setting time in minutes and the Ti is the initial setting time per minute.
In data and result of this report, we have 8 trials. Trial number 1, time of minute, 35 minutes, and needle penetration, millimeters, 40 millimeters. In trial number 2, time minute, 50, needle penetration is 39. Trial number 3, 65, needle penetration is 39. Number 4 is 120 and 39. 5 time minute is 135, needle penetration is 38. Trial number 6, time minute is 150, needle penetration is 38. Trial number 7, time minute is 165 minute, and needle penetration is 32.05. Trial number 8, time minute is 180, needle penetration is 22.05, and trial number 9 is time minute is 195, needle penetration is 21. For the result of the initial setting time of the cement paste sample is found to be 176 minutes, and the final setting time of the cement paste sample is found to be 300 minutes.
Computations. For this part, we will be using two formulas. So first, initial setting time. Initial setting times equals H, or the time in minutes of first penetration less than 25 millimeters, minus E, which is the time in minutes of last penetration greater than 25 millimeters, over C, the penetration reading at time E, minus D, which is the penetration reading at time H, times C minus 25 plus E. So by using the formula, based on the data given, our H will be 180, our minus E, which is 165, over C, which will be 32.05, minus D, which will be 22.05. It will now be multiplied by C, which is 32.05 minus 25, and added to 165, which is our time in minutes of last penetration greater than 25 mm. By using our calculators, it will be 175.575 minutes. So based on the C191, it should be calculated or rounded to the nearest 1 minute, so therefore it will be 176 minutes. For the final setting time, we will use this formula, 90 plus 1.2 times our initial setting time. So 90 plus 1.2 times 176, it will be 301.2 minutes. So based again on our ASTM C191, it should be rounded to the nearest 5 minutes. So therefore it will be 300 minutes. That all will be for our computation.
Here, meron tayong dalawang images. First natin sa procedure A, ipapaliwanag yung tinatawag nating manual Vicat apparatus. And for method B, meron tayong tinatawag na automatic Vicat apparatus. So, sisimulan natin sa manual. Sa manual, i-measure muna natin yung cement and yung water. Sa water, ang gagamitin na material dyan is yung glass graduates. And pagkatapos nyan, gagamitin natin yung mixer, bowl, and yung paddle para i-mix yung cement and water with respect to time na sinabi na rin kanina. And pagkatapos nyan, ilalagay natin yung composition natin dun sa conical ring. Then, para mapatag yan kapag nilagay natin, magamitin natin yung flat trowel. Then, i-separate muna natin siya, aside muna. While ginagawa yun, i-operate na natin yung tinatawag natin na indicator. So, sa indicator, ang gagawin natin dyan is isa-set natin siya sa 0 and ilalagay natin yung tinatawag nating needle, which is yung tin. Ayun yung una. And pagkatapos yan, ito, isa-set natin siya sa 0. Then, ilalagay natin siya sa tinatawag nating Vicat apparatus. And, ang mangyayari na dyan is yung penetration until yung needle natin is mag-touch siya sa surface. Then, pagkatapos yan, gagawin natin yun sa thick needle. Pero bago yun, ang tawag mo natin dito is yung time initial natin. para dun sa tin needle. And next nyan is, and ito na nga yung penetration. Ang sunod natin is yung thick needle. Same lang din siya ng procedure din sa tin. Ang pinagkaiba lang, ito nga, yung thick needle. Tapos isa-set din natin siya sa 0, yung indicator natin, and ang tawag doon, and lalagay din siya dito, and mangyayari din yung penetration, and touch din yung surface with respect to the time and yung measurement, at ayun yung tinatawag nating final time of setting. So, dito sa tinatawag nating initial time, ang time niyan is dito hanggang dito. Stop na siya dito. Tapos, dun naman sa final time natin, ang time naman dyan is magkisimula pa rin sa una hanggang kasama yung procedure sa tin and hanggang dito. So, ayun. Yun yung sa manual natin. So, next naman tayo, which is yung procedure B. Mas madali ito kasi ito yung magamit ka ng manual or gagamit ka ng automatic Vicat apparatus. So, ayan. Same na din siya. I-measure mo yung water and yung cement. Then, lalagyan mo siya sa mixer, sa bowl. Then, ilalagay mo siya dyan. I-mix mo. Then, ilalagay mo siya din sa conical ring. Ang pinagkaiba lang dito, may tinatawag tayong specimen mold. Which is ito. Kasi may required na gamit dun sa machine natin. Ay yung automatic Vicat apparatus. And, yung needle din, kasama pa rin dyan. Then, yung pinagkaiba lang dito, yung meron tayong man dito, which is siya na yung mag-ooperate ng time, ng measure, with respect dun sa time setting na tinatawag nating composition. So, gano'n lang siya, may the method A and method B.
Sources of errors. Fresh hydraulic cementitious mixtures are caustic and can cause chemical burns to skin and tissue if exposed for an extended period of time. Gloves, protective clothing, and eye protection are all recommended. After contact, thoroughly rinse the affected area with water. Wash your eyes for at least 15 minutes. Avoid wearing clothing that has been saturated with the liquid base of the unhardened material. Remove contaminated clothing as soon as possible after being exposed.
Conclusion and remarks. The results is you cannot expose it too long because the temperature may affect the cement.
Here are the reference that we use on this lab report.